We are good to go. Currently live. Stream is healthy. And alright. Everything seems to be good. And here we are. Back to the Visual Studio project. And first things first. We want to start by saving our checkpoint. So let's do some sort of a quick save of the current status. So yesterday I've been working on fixing a few things, and I've completed the implementation of the multi-sample render target. I've also implemented a new pipeline to get the shaders compiled. So I've added a PowerShell series of commands, and also the shaders are compiled twice in order to get one module that is multi-sampled, and that means that, let's get this fragment shader that has a multi-sampled texture sampler, right? Okay, so what else did happen here? There is a driver, which is the number of samples in the application class that then changes the behavior. And here with the render target creation, you can also specify the number of samples, and that is gonna load the right shader. So if the multi-sample is disabled, which means that we are only on one sample, then it's gonna load the normal fragment shader, which is gonna use a sampler 2D, just a regular sampler 2D. Otherwise, with the dot multi-sampled fragment shader, that will trigger on this path here, and we'll call the resolve, which is just going to average on the different samples. Okay. All right. Multi-samples, and that's pretty much about it. So implement multi-sample render target. Also switchable multi-sample render target. Switchable multi-sample. Okay. That should be enough. And we are almost done. Cool. We can now get back to the program and start running a session to see what is the current situation. No errors, and yeah, also I've also implemented really some basic interaction with the canvas, so you can now right click and drag to move the canvas, and also the it maintains the aspect ratio regardless of the size of the canvas, I mean of the window, and also the mouse input are now projected onto the canvas, so it's not relying on the 0 to 1 coordinate that is inside the window. So that happens here, which is a pretty simple matrix multiplication that gets the current projection of the canvas and just computes the inverted matrix and multiply each mouse location by that amount. Okay, and that gives us a pretty accurate representation of the mouse cursor onto the canvas. So as you can see, we can now just scribble something and that goes onto the canvas. There is something we can still fix, which is cumulative transformation, because at current stage, whenever you start rolling the mouse wheel, it will scale the canvas from its own center. So this is what happens, which is not quite intuitive. So the zooming should happen where the cursor is pointing, but we can come back to that later. So we are now on a 4K resolution image. It is quite sharp, as you can see, and we are not doing any multi-sample. But this way, where is it? Reset, probably. Wait, just one simple fix. So when I press the R key, we want to set the zoom to 1 and also the pan to 0. Okay, so we can reset the view whenever we get lost in the space, and that's it. So the issue here is that when I enable the multi-sample, I'm no longer able to use the linear interpolation, since we are calling resolve, which in turn is gonna call texel fetch. Texel fetch works on actual pixels instead of samples, so that makes a really hard it's basically a nearest neighbor interpolation. Well, I mean, it's not even an interpolation, which makes the canvas look grainy. Not not quite good. So if I zoom in with multi-sample disabled, you can see we get a quite nice interpolation, even though we are zooming in quite a lot. Let's see if we can still reset the transformation. Yes, it works. And so whenever we enable multi-sampling, let's say up to 8 samples, on my current hardware we cannot go higher than 8 on a 32 bits canvas. And when I start painting, actually we can also do that with my Wacom. I just unfortunately I just recently updated the driver, so that is not picking the pressure anymore. Okay, so now we can start to see that ugly effect here, where the interpolation starts to show that grid effect, which is really bad. So what can we do about it? How can we use linear interpolation with a multi-sampled render target? There is one thing that we can do, which is resolve the multi-sample image, which means it is then going to generate a non-multi-sample image by calling the resolve. And what do we need to do? We need to call the command resolve image. Okay. Where do we want to do that? How about on the canvas rendered thread? So whenever we render a series of command strokes, we then want to also append the last command, which is resolve, to another texture which is also kept. So I want to create another texture, another image, and the corresponding image view inside the render target, and call it resolved image and resolved view. Which is going to be created in the create frame buffer, which seems a good place to do that. So image view, but first image. And at this point I'm even wondering whether we can use the same memory location for both of them. which seems quite a nice improvement. So how do we do that? Create image, and okay, another image view which is resolved image info or result info. It doesn't have to be a 32 floating point image. We can scale it down back to an R8 RG8 RGB as norm, unorm actually. Okay, cool. And it's optimal. It is going to be sampled. It won't be a color attachment, and it is going to be a transfer destination as well. It is exclusive, and the initial layout is undefined. Okay. And the resolved image is going to be assigned to its creation. As soon as we've done with that, we can memory index. So okay, image memory index, image requirements, and then resolved requirements, and the resolved okay, here the resolved image request image. Okay, so we ask to find a suitable memory for that and this one as well, and if image memory index is the same as the resolved memory index, then we will merge them and allocate what resolved requirement dot size. So we allocate a good chunk of memory. And we can set the resolved memory, which we did not really define. So we did not define the resolved memory is gonna be a null pointer. Cannot do that, but I can reset. Okay, so we're gonna reset or release whatever was in there before. and at this point we need to bind to an offset of 0 to that memory, the main frame buffer image, and then we want to do the same with the resolved image, the same memory location, and we need to offset to the next location. All right, and that is whenever we find a suitable location for both of them. They're not exactly the same because they have different uses, so they may end up in different memory location. Once we've done that, we can also do the other path, which is we did not find a suitable location for both of them. So in that case, we are going to allocate another memory location. Resolved memory index image, resolved memory, and that is 0. Okay. And we need to save it to resolved memory. So we got the resolved image. Okay. Looks like we've got all we need except the image view. So at this point, we're going to create a resolved view info. Which is then going to be allocated into resolved view. It is attached to resolved image. It's going to be 2D, and it's got not that format, instead resolved info format. It's gonna be an RGBA resource, it's color. Okay, it looks all it's good now. And let's try to run this and see if we get any error. Which we don't, so everything we did is fine. And at this point we want to add that command to the queue. So what does this command look like? We need to create that command. So we need to allocate it in here. We need to build it first, right? Because that's how Vulkan works. And we've got a command resolve that is a VK unique command buffer. And that is going to be allocated from the command pool. Not directly, from the device. We call it to allocate a command buffer. How about just copying it from something we already have? The descriptor, so allocate. Oh, there's not much actually going on. Command resolve info. It's going to be primary. It comes from the command pool, and we only need one. Then we are going to allocate it. At that point, we need to get the command starting. We may need to do some pipeline barriers, at least for the image transition to the right layout. But first, command resolve. Let's start writing the resolve image command, which needs a source image, which is the render target dot. So that is the multi-sampled image. So that, and that's the frame buffer image, a source image layout, which is going to be a VK image layout. Is it what is it? It's probably a shader read only, and the destination image is in the render target. Render target resolved image. At this point, I think that I could just allocate the command itself inside the render target class, but I can do that later. So let me complete this command here. So we've got the resolved image, which is in turn going to be VK image layout, transfer destination. Is that something good? So let's say what is a valid usage. So the command buffer source layout must be a valid. Region, command buffer, all right, everything must be valid. Cool. Need the region. Command buffer destination must have been created, allocated, or tried to the same device. Region, p region, blah blah blah. So must have a sample count equal to any valid sample count value other than 1. So it must have some samples equal to any valid sample count value other than 1. Okay. And destination must have a simple count of 1. Fair enough. Source image layout. Source image must specify the layout of the image subregion specified in period at the time this command is executed. Must specify the layout. Must be either transfer source general. Okay, it should migrate to transfer source. And the destination must be in a destination optimal. Was created with tiling equal. Destination must have been created format that it supports being a color attachment. What if destination image was created with tiling? Equal tiling linear. It's optimal, but destination image must have been created with a format that supports being a color attachment as specified by VK feature color attachment bit linear tiling feature. What? Okay, this is something that might break everything in some devices because of the darkness of this specification. Okay, it's outside of render scope. Sports graphics queue. So what did we learn from reading this documentation? That we can either do a general, I'm not sure about that. I don't know. Let's see. The resolved image, so it must be and transfer optimal, and we can do that by introducing a pipeline barrier here, the same way we have done with render target or render stroke. And at this point I'm just going to copy it over here. This will get the render target dot resolved image and perform a transition from whatever to transfer right. It's going to be moved to transfer destination optimal, okay, on our resolve command. That will happen from the top to a transfer stage. Okay. Now we want to finish to pass everything to this function, and it will get a VK image resolve, which in turn gets a sub resource in offset to destination. There's a lot of stuff that would have been better if we could get some of the default values. So VK image resolve, VK image resolve, underscore resolve dot. Let me dock the documentation here on the right, and the first thing that we need to pass is the source sub resource, which is an image sub resource layers. Image sub resource layers. Wow. So what about is it a pointer? Hey. Okay. Dot. Spect mask. Blah blah blah. MIP level. I think that equals to. No, this is a subrange. I don't know. There are many of these sub-resource stuff, but this one is another one. So this is, come on, seriously, what the hell? That's a lot of lookup fixes. So image sub-resource layers. Okay, any help from this? I guess not. So we may need to do it manually. And we have an aspect mask with aspect mask. Okay, which is the color aspect mask. Then we got the MIP level, which is 0, the base array layer. I think it's gonna be 0. And layer count, which is just 1. Okay, now back to resolve, source offset, which I believe is going to be 0, which is offset 3D. We can leave that with VK offset 3D of 0. Zero and 0. Is that VK offset 3D? What? VK offset 3D an empty one, so then resolve dot destination subresource, which is going to be the same. Okay, and resolve dot destination offset, which is again going to be offset 3D empty. Oh, and we still got the extent, which is rt dot, we don't have an extent, which is a vk extent 3D of an rt dot size dot x, rt dot size dot y, and one layer. We can pass this struct in here, and we should be good with the command. Now, during the render, we will move the assignment here, and let's say we create +1. That +1 is going to be the int I here, and this gets copied over here, and again we will set the last command +1. The last command is going to be the command resolve. Will this work? Who knows? Let's see. Okay, we already getting errors. We are already getting some errors during the compilation. So the layout, VK image, render target. Oh, we got a nice naming now. The render target color image is VK image layout shader read only, but can only be transfer source or VK layout general. Okay. At this point, we can do another image barrier. Or what if we just ignore so I would like to just ignore that, the fact that we are in different layout. And what if we just say a general layout at this point? Is that acceptable? Okay, this is quite interesting. Code with a test sample count greater than 1. What? Destination is greater than 1? That should not possibly be. It cannot possibly be. Samples, okay, that is wrong. That's going to be 1. And I'm quite curious to see what happens here, if they are going to end up in the same memory location, in the same memory family index 7 and 7, which is quite nice. Okay, seems like we are not getting any error, and it's also drawing, which is even nicer. But are we getting what we expect? I mean, at this point, if we draw the resolved image, are we going to get the right stuff? Let's see. On the resize from screen the sampler. We want you to use the linear sampler and the result view instead. Can you do that? Is the question. Let's see. It can do that. It is pretty fast. Well, actually, it's not. I mean, it can get clogged by the number of samples, but well, at least we are getting that nice linear interpolation. Are we? I think we are. Maybe not. Is it linearly interpolated? Transfer on. Okay. Something is happening here. So there is draw state of what? I should start to name objects at this point, because otherwise it's hard to know what's going on. So draw state invalid, submitted command buffer which expects layout shader read only, but it is a transfer destination. Okay. And what do we do now? Let's create another image barrier. So everything remains the same. And we want to restore the state of this image and make it ready to be sampled from the shader. Shader read only optimal. It comes from the transfer to the fragment shader of whoever calls this. or the bottom of the pipe. So let's see what happens if we also include this other image barrier. It is undefined, fair enough, but now it is in a good state, and it looks like it is also interpolated. I mean, I think it is. I think it is. And this will only happen if, and let's say if samples are different than vk sample seriously, this IntelliSense is just not able to deal with Vulkan. Wow, it is dying parsing the Vulkan header. I mean, what the hell? So if we are not sampled, just do that. Otherwise, add 1. Okay, so this way we can still disable that multi-sampling, and also wait. Let's get a step back, and what I forgot is that here we are not doing multi-sample anymore. So when initializing the swap chain, we will not create this anymore. So we don't need any multi-sampled image from here. So there is nothing to specialize. Okay, nothing. That's all we need. Okay, it is getting better now. This is what I call linearly interpolated. Now I recognize you. Okay, reset, and that is it. So we are now getting a real deal. But can we also deal with that poor render target that needs to be relayouted? I mean, do we really just want to ignore the fact that is in an undefined state? And apparently we do. And now let's do the very last test, which is coming back to the MSAA. And we are not getting anything out of here because we probably messed up with the commands here. So if the samples is equal to 1, then just draw the thing, otherwise do the multisample. And okay, we are now back on track. We are getting linear interpolation, we are getting the multisample, we are getting really slow, fair enough. And I'm also wondering whether we can get smarter by submitting I mean, do we really gain much by submitting only once? And by that I mean, where the hell is the +1? Here. So what do we want to do? We want to get all the samples, really just get all of them. Just all of them. So samples is did move stroke samples, and while samples are empty, while it is not empty, we want stroke samples arrays into what do we want to do? Int offset is 0. Okay, and we've got the samples count. Let's move this logic here. We want to submit all of the chunks before doing a resolve. So we are here, and if it is single sampled, all you need to do is to submit and wait. Okay. Otherwise, what? Otherwise, if samples So let me fix this first. I offset plus. Nope, that's completely wrong. So that only applies to the samples. Okay. Okay. We need to pull the index out again. And so if samples are just one, all we do is that we send them and to the queue and wait until it's done. Offset equals sample count. Otherwise, if so that gets back sample count. No, I mean offset minus offset. So that will never get emptied. Okay, so let's get this straight. We can count the number of times we need to submit by dividing samples. So we just copied over everything, and let's say int n is equal to samples.size divided by the size of the commands that we have available. And we need a ceiling of that. So that is the number of times we need to iterate. And and here we can switch this back to a for loop, int block n plus we compute the offset by saying that it's block by the size of each block, and the samples count int samples count is given by the minimum between n and samples size minus the offset. So we get the minimum int between the whole block and the remaining. We could already test if that works in a single sampled render target, and if it works in that way, can also bring it to the next level. Layout optional instead pk layout undefined. Okay, so I need to also say that if we are on int samples is greater than 1, then use the result, otherwise it is safe to use the render target frame buffer image, not the image, the view directly. And we are definitely messing things up. It looks like that this logic is not working at all. So we get a few samples, and n should be 1. So in a single block, offset is 0, samples count is what? 1. Samples n, not n, what the hell? between, we need the minimum between the strokes size and that. Not quite working the way I would have expected. So let's stop there if n is greater than 1 at least. So that is 2 now. Samples count will be 1000. Okay, which is the size of the command queue. And now you do that and we get that offset is 1000. Submit everything, wait for it to be done. Next block has an offset, or what the hell? An offset, which is not n, is stroke, the size of the command buffer. Okay, let me try that again. And okay, it is now sending everything. It's not even the resolve, really. It is just unable to keep the pace. So at this point, we get that if the block is equal to n minus 1, we are at the last block. We push oops. push that last command in and expect that to fit. Because strokes size, buffer size, let's say we have an int buff size equal to that -1. So that is buff size. What? This is buff size. So we use that instead. Okay, here, last index to the resolver, and again sample count +1 for the resolver, commands lock fence wait, so whatever we do we can just wait up in here. The weight is the same. Well, actually, one else, this is it. Wait. We can add that here. Or it's not the last block. So this way, this will be triggered only when we are on non-multisampled or we are still processing an inner block. again. Let's try this. It works and we are getting 40k 56 frames per second. Oh, there is something here called with source sample count less than 2. Wait, what? We are on a non-multi-sampled environment, so this should never get called. And it is not. But it looks also like we must not even create the command buffer. And I think it's also time to move this command buffer back to the render target. And we can easily say that we'll create resolver can be implemented to do that, and all we need is const vk unique device ref to dev and const vk unique command pool ref to command pool. Render target is already referenced. And we must save, promote this. Can I promote, remove definition location? Where did this even end up? Oh, it changed the whole function. Not really what I wanted. So I will just do it here. We want the command resolve to be global. I mean to be a member of the class, and everything else is transient. Now let's update the prototype. And come back to the main, and at this point we can reference the command resolve. Create frame buffer, so at the creation stage we want to make this public so it can be called in here whenever the render target gets created. We also want if samples greater than 1, we just want to render target dot create resolver, and the resolver gets the device and the command pool. Which comes from the main command pool. And I'm wondering whether they should come from the same command pool in order to get synchronized. That's actually a good question. Anyway, this must return something, so let's return true, because we trust our code. No errors. Okay. Good. No errors in a non-multisampled environment. What if we now unleash the beast and enable multisample on the canvas? We get that the layout is undefined instead of read-only shader. And I'm wondering whether it is best to do the transition here or there. To layout. Okay, let's say that whenever we create the resolver, we also want to make sure that we transition the layout to an appropriate location. The source access mask is undefined. The destination is VK access mask. Access flags beats shader read is VK layout undefined. The new layout is VK image layout. Shader read only optimal, don't care about that. The image is the resolved image. Region pipeline barrier. The source stage is VK pipeline stage, VK pipeline stage. Pipeline stage flags. Pipeline stage flag bits. We want it from the top to be ready by the fragment shader. And we need the queue. We need the command queue. All right, and wait for it. Or maybe we don't even need to do that. We then need to update the prototype again and also get back to the main, where we probably need to also add the main queue reference here. And we should not get that ugly error anymore. Okay. Destination member of pipeline barrier is not supported, but destination stage mask can't use. We does not match transfer. That is literally what happens here. Oh shit. We are done. Probably gonna need to shut down every fucking shit. Okay, my PC is dead. It's gone. No matter what I do now, there is no way I can recover from this. I might even think the stream is gone. If for any reason this is still working, I will need to stop for a few minutes and come back later after restarting Windows, because there's no way I can recover from this process being locked. There's no way I can terminate it. There's no way I can go to the detail because everything is now dead. And I'm not even sure what is using 100%. It might even be render doc. Okay, be back in a bit. Again. Let's see. Render target. Destination is transfer, right? Transfer destination. Image barrier destination access mask 20. Which one is the destination access mask? This should be 0, so I believe this must be the one that expands to 20. Okay, do your thing. Be quick, please. So 20 is access shader read. Oh, okay, that's the destination, not source. Shader read, and bottom of pipe fragment shader then. And we've got rid of that. We're still having the command resolve. Cannot use VK image. So let's name a few things. And instead of doing it here, we want to do it here. Debug name of image. It is unique. What's wrong then? Probably because it is not included. Okay. Get that. And here, debug name this as this. Again. And again in this form. Then okay. Render target. Otherwise it may get confused with something else. Views. The frame buffer. command and also why not this command here. Okay, what about here, the pipeline? Debug name got that pipeline. The layout. The modules, maybe. Yeah, I should probably be doing it here. Go to debug name and the path dot string dot c string as wchar. Don't want that on the string, and we want the c string. Debugger name is undefined. Now it is defined. Okay. From here, everything is named. We should probably do the same thing out in here. But let's try if we can get a better error naming this way. Yeah, it's quite better. That is unbelievably better, actually. Okay, resolved image. Which is expected to be in transfer destination. Okay, so it is expected to be at transfer destination render target. This is supposed to be at transfer destination, but that should be done in here. So at this point it should already be in a good state. And I'm wondering whether I should move this down here. Let's see if that changes anything. And it does. It is surprising how the order of calling these affect everything. So okay, that is something that I have to recall. The order of the commands matter, especially the image barrier. Cool, and at this point there is need for clearance. I mean, the command resolve does that. But we also need to do this transition and I also want to clear the render target. I mean that image, I want to clear that image, which is something that I already did. Was it in texture? No, it wasn't in the texture. It was in the application level. Clear. Create. Oh, that. Yep. That was during the creation of this, where there was a clear attachment. Instead, I just want to clear an image. Can I do that? Command dot clear color image. Color image only takes an image and all it does is clear color image. Let's see what is the layout. clear color image. Yeah. So clear color image. Destination, it must be in a destination optimal, which is already what it needs to be in. Is it not? It's not. It's not. So can we just ignore it? Of this drawing application. Okay, full screen and my stylus. Let me draw something. Okay, it's getting slower. That's why we can play our jolly and switch to release and release the Kraken. Let's see how it performs in release mode. There must be a huge difference. And there actually is. I cannot even draw so fast too. To flood it. Okay. Okay. This seems to be all for today. The last thing that I want to do before leaving is to change the save behavior. Render target, save, that's not in the render target, it's in here. So let me jump right straight to the save function, which I believe it was here, and maybe it's even in here. Save image, yes, that's here. So that is called from here somewhere. Save, here it is. What we want to do is to check whether samples are greater than 1, and in that case we want to save render target dot result image. Otherwise the frame buffer itself is good enough. Scribble something, hit save. Let's check here. Nothing gets spawned. Well, that's also because we are in release mode. Let's try that again and save. Nothing happened. Hit that again, and yes, it is now doing it. It may have done it, but it seems like it is white, an empty canvas, and it also has the wrong yes. That is because save image expects what? A different type. So we should float floating pointer. HDR. Okay, let's just say bool HDR. Okay. And update this in here to say that multiply by HDR, then it's the size of the float. Otherwise, it's the size of your Win 8. Okay, which should be 1 anyway, but at this point we also want to if it here, if it's HDR, you wanna be saving the HDR. Otherwise, it would be good to get an uint8 and that one again and save a JPEG. We need a quality of 100 and that saves the JPEG. Now we can jump back to the caller and say that if samples, if we have a multi-sampled image, we can use the result image and output a JPEG. Otherwise, we will be using the frame buffer itself, which is a 32 floating point, and save it as an HDR. Let's do some logging now. Log that we are saving to path.string.cstring or instead cout fmt format, or let's just saving to path. Okay. Or even better, when it's done, we can instead cout done. And let's try that again. Almost done, almost done. And here HDR is false, while here we want the HDR. Almost there. Come on, we can do it. Scribble something, hit save, nothing really happens, hit save. What's wrong with it? It's not even save, it's space. All right, we get something, that wasn't really supposed to happen, and that's it. So saving to output JPEG, old layout with AK pipeline image barrier. New layout is not compatible with VK image. Resolved image flags. Okay, so it must also be a source. Yeah, forgot about that. And render target on creation. Let's jump straight to the resolve creation, and here it must also be a source. It is a destination from the frame buffer, but it also is a source to when we are saving. And that is working, I hope, and it's done without any error. That is so cool. We saved a JPEG this time, out.jpg, and it is what we would have expected to be. Zoom in. It's pretty cool. So we can now also save whatever we are painting. Cool. Okay, fair enough. We can save the shit out of it. And we can call this multisample resolve. That's it. Everything is good now. And we can say this stream is over. All right. We reached my goal. And we can call it done. See you in the next stream.